Welcome to today's deep dive. Today we are looking into this huge headache for supply chain managers.
Oh yeah, it is a massive issue right now.
Right. So they're pulling their hair out because, the network dashboard shows perfect full Wi-Fi signal bars,
Mhm.
but out on the floor, their autonomous robots are just freezing dead in aisle 4.
Yeah, and that is a huge vulnerability for these facilities because um, a wireless problem in a warehouse, it rarely announces itself as an IT issue.
Right. It's not like a blinking red light on a server somewhere.
Exactly. From the floor, it just looks like an operational glitch. I mean, it looks like a forklift terminal dropping a session right as a driver tries to log in a pallet.
Oh man, that's frustrating.
Or, an employee having to enter the exact same inventory transaction twice
Right.
because their scanner just timed out mid-scan.
And meanwhile, you've got the IT department, right? And they're looking at their monitoring software and everything is green.
Green across the board, yeah.
The heat map shows total coverage. But I was thinking about this. It's kind of like using a microphone that only registers raw audio volume, right?
Okay, yeah.
Like it tells you the room is incredibly loud, but it doesn't tell you if you're listening to a beautiful symphony or like a blaring smoke alarm.
That is a perfect analogy because a heat map only answers one basic question. Is the access point signal physically reaching this specific location?
Right. Just is there volume?
Exactly. It completely ignores the actual environment of a dynamic warehouse. I mean, these buildings are not empty boxes.
No, they're definitely not.
You're dealing with floor-to-ceiling metal racks. You have extreme ceiling heights, heavy machinery.
Right. And the inventory density is literally changing by the hour, right? As trucks get loaded and unloaded.
Exactly. And all of that drastically alters the RF propagation.
Mm-hmm.
So you can have a very strong signal reaching a device.
Right. Okay.
But if the background noise bouncing off all that metal is just overwhelming, the actual data gets completely drowned out.
Oh, I see.
Yeah, your signal-to-noise ratio is poor, which makes those full bars completely useless.
Wait, so, okay, if the signal's just getting drowned out by all this environmental noise, then why not just throw an access point in every single aisle? Like, just blast through the interference with more hardware.
Oh, man. That is the ultimate trap.
Really?
Yes, it comes down to a constraint called airtime.
Airtime, okay.
Yeah, so wireless devices have to share the airspace. They cannot all transmit at the exact same time on the same channel.
Oh, I didn't realize that.
Yeah, it creates what engineers call collision domains. So if you just blindly add more access points without carefully mapping these domains, you end up with overlapping channels.
Oh, so they're fighting each other.
Right. Think of it like a crowded conference room where only one person is allowed to speak at a time.
Okay.
If you add more access points, it's the equivalent of putting more people with megaphones into that room.
Oh, wow, that sounds like a nightmare.
It is. They just end up talking over each other. The interference skyrockets, and every single device has to wait much longer for its turn to transmit data.
So the network performance just absolutely tanked.
It completely tanks, yeah.
Wow. Okay, well, here's where it gets really interesting to me. Looking at the source material, they mentioned that if you're the one walking the floor with a laptop running a diagnostic test, you might actually see a great connection.
Sure, because you're stationary or, moving slowly.
Right, maybe you're standing in a clear aisle, but that doesn't mean your worker's wearable scanner isn't dropping out on every third box they scan.
Exactly. And that's because roaming, the act of jumping from one access point to the next, is determined by the client device itself. It's not determined by the network.
Wait, really? The device decides?
Yes. So a connection that survives a simple walking test behaves totally differently on an autonomous robot zooming down an aisle at 10 miles an hour.
So how does the device actually make that decision to switch? Like, what's the logic there?
Well, it's based on the specific device's internal roaming logic and its sensitivity to latency. A really common issue is what we call the sticky client.
Sticky client, what is that?
So a wearable scanner might be programmed to hold on to a deteriorating signal way too long because it still detects a faint connection.
Oh, so instead of handing off cleanly to a much stronger, closer access point, it just clings to the old one.
Exactly. So the worker walks down the aisle and their scanner is clinging to the router all the way back at the loading dock.
And then the transaction fails.
Right. The network was technically available, but the device's logic just failed to utilize it properly.
Wow, which means an architectural plan based just on the building's square footage is essentially useless.
Completely useless until you understand how the specific tools act in that physical space.
Right. Which makes sense why the source article talks about shifting how we procure these networks. It highlights network as a service models.
Yes, like companies like Meter.
Right, where the hardware, the installation, and the monitoring are all wrapped into one adaptable utility. So instead of buying static hardware and crossing your fingers, the network is treated as an ongoing service that adapts to the floor's reality.
Exactly. Or, if a company wants to optimize their existing hardware, the source points to groups like provision networks.
Okay, what do they do differently?
Well, they conduct really rigorous, real-world operational assessments before anyone buys a single new router.
Oh, that's smart.
Yeah, the entire goal is to map the physical gaps, the RF behavior, and that specific client device logic under actual working conditions.
So you have to evaluate the operation first.
Yes, evaluate the operation first and let that dictate the architecture.
Because in a modern warehouse, wireless performance is no longer just an IT metric.
No, not at all.
It's basically the invisible conveyor belt.
Without a doubt, it is a critical operational requirement because the moment the Wi-Fi fails to deliver clean airtime, the physical movement of goods just grinds to a halt.
Wow. Well, that leaves me with this one final thought to mull over for today's deep dive.
Let's hear it.
If Wi-Fi is so deeply compromised by physical layouts, by the metal racks and the daily density of cardboard boxes,
Right.
how are we going to handle the upcoming wave of shape-shifting modular warehouses?
Wow, yeah.
Because we're heading toward a future where entire rack systems and temporary walls are autonomously rearranged by robots overnight just to optimize storage space.
That's wild.
Right. So how do you design a reliable RF network for a building that literally changes its physical shape while you sleep?